topic, that is what are possible types of operations in an image. So basically, whenever we are processing the image, either we can go for point processing, local processing, or global processing. So point processing means we say if we want to process this particular pixel, we apply some operation only on this pixel in order to determine its new value. That is nothing but point processing. Then local processing. Local processing means in order to determine new value of this particular pixel, we consider some neighborhood around this pixel, and then by taking into account this local neighborhood, we modify pixel value. So it is as shown here. In order to modify value of the given pixel, we consider the neighborhood, local neighborhood of the pixel. We take into account pixel values of neighboring pixels, and then we process it to get new value. So this is meaning of local processing. And global processing means in order to determine new value of a pixel, we take into account entire data available in the image. That's why it is named as global processing. Okay. So for neighborhood, we can have different types of neighborhoods as shown here. We can consider this four neighborhood as shown here. So this is four neighborhood. We are considering two vertical neighbors and two horizontal neighbors to determine new value of this pixel. So this is four neighborhood. Then in this slide, you can observe 8 neighborhood, which is indicated as N8P. Okay, so this is 8 neighborhood. Then in this third image, you can observe diagonal neighborhood, where we are considering only diagonal neighbors. And we can name it as NDP. Okay, P is the pixel under consideration, and we are considering diagonal neighbors as local neighborhood. And instead of square grid, while capturing the image, if you have hexagonal grid, you can have hexagonal neighborhood. But practically, this hexagonal neighborhood is not used for simplicity of implementation and simplicity of computations. Most of the time, we consider rectangular neighborhood as shown in these three pictures, rectangular grid. Okay, and hexagonal grid is rarely used. Okay, so for rectangular grid, we can have these three types of neighborhoods, or we can have any other shape like approximate circle. Okay, or instead of 3 by 3 neighborhood, we can consider 5 by 5 neighborhood or 7 by 7 neighborhood, depending on which processing technique we are using and what is the application. Okay, so this is concept of local neighborhood. So this is your 4 neighborhood, 8 neighborhood. Now let us talk about distances. What are the different types of methods to compute distances between pixels? So here basically, say if you have two pixels in the given image, say pxy is your one pixel and qst is another pixel. Okay, then for these two pixels, there are general properties for distance functions. Okay, so distance between P and Q can be greater than or equal to 0. Okay, so if your pixel PXY is same as QST, then distance between them is 0. Okay, if these two pixels are representing same location in your image, that is if your XY coordinate values are same as ST, then of course distance between them is 0. And if XY is different than ST, then the distance is always greater than 0. Okay. So this is first property. Second property is distance between P and Q is same as distance between Q and P. Okay. So this is absolute, basically absolute value. It distance can never have negative sign. Okay. And if you consider distance between P and Q, it is same as distance between Q and P. And third property, that is, if you consider one more pixel Z with coordinate values V and W, then distance between P and Z is always less than or equal to distance between P and Q plus distance between Q and Z. So these three basic properties of distance functions, they are same as your distance properties as per geometrical concepts. Okay. So these are the three properties of distance functions. Now let us have a look at various methods to compute distance. Okay. So first method is Euclidean distance. Again, I hope all of you are familiar with Euclidean distance. So the Euclidean distance between two pixels P and Q is defined as dpq is equal to square root of x minus s square plus y minus t square. Okay, so this Euclidean distance here as shown here, it follows basic trigonometric property. If this length is s minus x and the height is t minus y, then the distance r is given as square of this length and square of this height t minus 1. So the formula is as given here. So this is Euclidean distance method for computing distance between two pixels pxy and qst, where xy are coordinates of p and st are coordinates of q. So hope this is clear to you. Then next method for distance computation is city block distance method. Okay, so for city block distance method, we use the concept of planned cities. If in a city there are vertical, say there are vertical distances and horizontal distances. Say this is your source place and say this is your destination place. Okay, say this is your source and this is your destination. Now in order to travel from this place to this place, how we travel in a city? First we take this path in this particular lane and then we take this path, right, in horizontal lane. Okay, so we travel here 1 unit distance, then 1 unit distance. So this 1 plus 1 distance is 2. Okay, so this is concept used in city block distance method. We first travel in this direction and then in this direction. Okay, now if we want to reach from this place to this place, first we travel here 1 unit distance. Again, we travel in the same direction for 1 unit distance. So this total distance is 1 plus 1, 2. Okay. So are you getting the concept how it is different than Euclidean distance? These planned cities concept, I know it is not possible in India. It is not available. We try to follow optimum path. We usually try to use this Euclidean method because if we want to reach from this place to this place, though the proper path is not available, we will try to find some way which is optimum way. Okay, but this is not concept for planned cities in other countries. You have to strictly follow horizontal and vertical directions to reach from one place to other place. And in this method, distance calculation method, this city method is used, and hence the name is city block distance method. Okay. Okay. Now the third method chessboard distance method. So in this third method, basically it treats all diagonal neighbors as well as horizontal and vertical neighbors at same distance. So if this is your point of consideration or this is your pixel under consideration, all immediate neighbors, they are treated at same distance, that is distance 1. Then all next neighbors, they are treated at distance 2. Then if we consider one more layer, a third neighbors, they are treated at distance 3. So this is chessboard distance method for distance calculation. Okay, now let us have a look at actual formula for computation of city block distance method and computation of distance by chessboard distance method. Okay. So for city block method, this is also known as D4 method. Why? Because it treats your 4 neighbors at same distance. That's why name for city block distance method is also D4 distance method. So the city block or D4 distance between two pixels P and Q is defined as D4PQ is equal to absolute value of x minus s plus absolute value of y minus t, where x, y are coordinates for pixel p and s and t are coordinate values for pixel q. So this is your city block distance method. And uh, for city block distance method, if we consider this diamond shape, this is your pixel under consideration. So the 4 corners of uh, uh, or say boundary of diamond gives you same distance value. Similar, so here first diamond for distance is 1. For this second diamond, distance is 2, and so on. Okay. So this is your city block distance method formula. Then third method, that is chessboard method or D8 distance method. Now as all the 8 neighbors are treated equally for chessboard pattern, this is also known as D8 distance method. So formula for chessboard method is as given here. D8PQ is maximum of absolute value of x minus s and absolute value of difference between y and t. Maximum of this gives you chessboard distance. Okay. So this is your chessboard distance for given image. This is pixel P. Then all first neighbors, they are at distance 1. Next neighbors, they are at distance 2. Okay. So let us understand it further by using one particular example. So this is given example. So here you have an image with size 4 by 4. Okay. And the pixels are named as A, B, C, D, and so on, as shown here. P, Q, R, S, K, L, M, N. Now here the task is to determine distance between pixel K and pixel H by using these 3 methods. Okay. So in order to determine this distance, let us determine first coordinate values for pixel K and pixel H. Okay. So here these are the coordinate values for pixel. So these are x coordinates 0, 1, 2, 3, and these are y coordinates 0, 1, 2, 3. So coordinate value for A is 0, 0, for B it is 0, 1, and so on. So for K and H, you can first step is to determine the coordinate values. Okay. Uh, there is one question from Manas. Can you explain again why chessboard distance is denoted as D8? I will explain it with this numerical. Okay, Manas? Okay. So first complete the numerical. So for Euclidean distance, first we first we determine the coordinate values for pixel K and pixel H. So with this particular convention, tell me what is coordinate value for K. and coordinate value for H. So for K, yes, your answers are correct. X, Y is 3, 0. And for H, coordinate value, H is in first row and third column. So it is 1, 3. Okay. So distance PQ, Euclidean distance, you can compute by this formula. Just take difference between X and S, take it square. Take difference between Y and T, take it square, and add these two squares and take the square root. Okay. So 3 minus 1 gives you difference as 2. 0 minus 3, difference is 3. So 2 square is 4, 3 square is 9, 9 plus 4, 13. So your distance is square root of 13, right? So this is by Euclidean distance method. Now try to find out the distance by city block distance method. Okay. So for city block distance, we use this formula. This is your K, this is your H. Okay. So consider absolute value of difference between X and S. Consider absolute value of difference between Y and T and add the two. So type your answer for city block method. Absolute difference. Yes, all your answers are correct. Mehak, Soumya, your answers are correct. So difference between X and S is 2. Difference between Y and T is 3. So 3 plus 2, it is 5. We can also verify it by city block concept. If we want to reach from K to H, first we will take one step here, then one step here. So this is 2. And then horizontally, we take 3 steps, E to F, F to G, G to H. So total 2 vertical steps and 3 horizontal steps. So distance is 5. Though you follow any other path, you will get same distance. Say if you first move from K to L, L to M, there are 2 steps, then 2 vertical steps, 2 plus 2, 5, and then G to H, one more horizontal step. So 2 plus 2 plus 1, distance is 5. Okay. Mathematically, we can represent it in this formula and we can easily compute it. 2 plus 3, 5. Okay. So this is distance by city block distance method. Then third question, that is compute distance by Euclidean distance method. Sorry, compute distance by chessboard distance method. So for chessboard, formula is maximum of x minus s and y minus t. So out of these two values, these two differences, your first difference, this 3 minus 1 is 2 and 0 minus 3, difference is 3. So maximum is 3. Yes, Soumya. So by, yes, Sakshi. So by by chessboard distance method, distance between K and H is 3. You can also compare it with conceptual understanding of chessboard. All immediate first neighbors, PQL, they are at distance 1. Then all immediate second neighbors, that is E, F, G, R, M, they are at distance 2. And immediate third neighbors, that is A, B, C, D, H, S, N, all of them are at distance 3. Okay. So by chessboard distance method, we for H, distance is 3. Okay, so hope the concept of chessboard distance is clear. Now I'm going to that question, that is why it is known as D8. Okay, so basically, if we say we are considering pixel F here. Okay, so say if we are considering pixel F, all these 8 neighbors A, B, C, E, G, P, Q, and R. All these 8 neighbors are at distance 1 with respect to distance F. Okay. all these 8 neighbors are at distance 1. They are treated equally. That's why the name is also D8. Okay, this chessboard method is also known as D8 method. Is it clear why it is also named as D8 method? Hope it is clear to you. Whereas for city block distance method, only 4 neighbors, 2 horizontal neighbors and 2 vertical neighbors, they are treated at distance 1. That's why city block is known as D4 method. And in case of chessboard, all 8 neighbors are at same distance. That's why it is also named as D8 distance method. Is it clear? Okay, thank you. So I think its time is almost 12:30. So I request all of you to type your 5 digits, strictly type 5 digits of last 5 digits of PRN number, then space, and then your name. Don't write any other symbol, dash, etc. in between name and PRN number. Okay, so that's all for today. Okay, and we will continue with this in the next lecture. Thank you all.